The goal of this learning objective is to understand present value concepts and the use of present value tables and financial calculators. The concept or idea behind the time value of money is the thought that a dollar received today is worth more than a dollar received a year from now. And that's because we can put the money in the bank today and earn interest on it or earn a return and have more than $1 a year from now. Let's take a look at an example. Assume a bank pays 10% interest on a $100 deposit made today. How much will the $100 be worth in 1 year? Our future value is given by the F sub n, or FV often. Our present value is the P, or often PV, times the quantity 1 plus R, where R is our interest rate and N is the number of periods. So for our example, we want to know how much will it be worth in 1 year if we deposit the present value of $100 today and then earn 10% interest for 1 year. And we can see using our formula that our account would grow to $110. What if the $110 was left in the bank for a second year? How much would the original $100 be worth at the end of the second year? Well, we've got $100 as our present value, and we'll multiply that by 1 plus our 10% required return. And this time it'll be to the second power for 2 compounding periods. The interest that is paid in the second year on the interest that we earned in the first year is known as compound interest. Let's look a little more closely at our example. We've got an Excel worksheet here that shows our initial beginning balance of $100. And in the first year at 10% interest, we would earn $10 in interest, giving us that $110 at the end of year 1. Or alternatively, again, we could find the future value by simply multiplying the present value, which in this case was $100, times 1 plus our interest rate to the first power. If we leave our money in the bank for a second year, notice we begin with $110, so now when we earn 10% interest, we will earn $11 in interest, and our balance will grow to $121. Or we could have calculated it directly with our calculator by simply taking $100 and multiplying it by 1.1 squared. If we're to leave it in a third year, our account would grow to $133. And again, notice over time, our future value will increase, and also over time, the amount of interest we earn increases each year. And again, that's because we are earning interest on our interest. The first year, our interest is only on the $100 initial balance. The second year, we earned $11 in interest, which was interest on our initial $100 plus the $10 in interest that we earned in the first year, and so on. If we were to solve this using our financial calculator, we could enter 3 for the number of periods, 10% for our interest rate, $100 was our present value. We'll put 0 in for the payment. The payment field will be reserved for annuities, which is a series of equal payments over time. And then finally solve for the future value. And notice we get $133.10. In our financial calculator, one thing you'll notice is that if you put the present value in as a positive number, in other words, you put in $100, you will be able to take out $133, and that's why it says a negative for the withdrawal. If instead we had put in a negative $100 for the present value, the future value would be a positive amount. It's not really important whether we put it in as a positive or negative amount, as long as we know whether it's cash going in or cash coming out. Again, looking at our financial calculator, if this was for 4 years, we would have simply changed in our financial calculator to 4 periods, and we would solve for the future value and get $146. And again, we could also calculate that directly, $100 times 1.1 to the 4th period, or 4 years. Another way we could solve this problem is by using a future value interest factor table. In our case, we've got a 10% interest rate, so we will highlight the column here that has a 10% interest rate. And in our particular problem now, where we have 4 periods, we'll come down to the 4th year and again highlight it. and notice a factor of 1.464. That's essentially this: 1.1 to the fourth power equals 1.464, and we would simply multiply that by the present value to get our total future amount. Notice, had we changed our worksheet and used $1, here's the factor of 1.464. If we had decreased it to 3 periods, we've got the 1.331. Had we decreased it to 2 periods, we would get the 1.21, and so forth. So we've got 3 ways we can solve this problem for calculating a future value. We can use our future value factor table, which essentially does this simple mathematical calculation for us. We can do the mathematical calculation manually in our financial calculator, or we can use the financial functions. Let's take a look now at calculating present values. An investment can be viewed in 2 ways. It can be viewed as a present value or as a future value. Now let's look at a situation where the future value is known and the present value is unknown. A little simple algebra will show us that our present value is simply equal to our future value divided by 1 plus r to the n. So now let's ask the question, if a bond will pay $100 in 2 years, what is the present value that an investor can expect to earn if it can earn a 12% return on the investment? In other words, how much should an investor be willing to buy that bond for, or would they need to set aside today if they could earn 12% to be assured of having $100 in 2 years? Using our equation, we would take $100 and divide it by 1 plus 0.12, or 12%, to the second power. And we can see the present value of that investment would be $79.72. The process of finding present values is often called or referred to as discounting. We have discounted the promise of $100 in 2 years. We'll accept less today. How much will we accept today? Well, if we can earn a 12% rate of return, we would be willing to accept $79.72 because that would grow to $100 in 2 years. Let's go ahead and take a look at that. The initial $79, if we could earn 12% interest, would earn $9.57 in interest in the first year, leaving us with an ending balance of $89.29. In the second year, that $89.29, if we could earn 12% interest, would earn $10.71 in interest, and indeed we would end up reaching our ending value of $100. So in terms of calculating present values, we can use our formula, which simply says the future value divided by 1 plus r to the n will give us our present value. We could also consider using our financial calculators.